Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. We are in the second module of this course, Elements of Mechanical Engineering, where we are studying boilers and turbines. In the previous lectures, we have completed the working of different types of boilers, different types of turbines, different types of pumps. In this lecture, we are going to see some basic definitions and terminology that is related to both boilers and hydraulic machines. Hydraulic machines include hydraulic turbines and hydraulic pumps. We know what is the difference between hydraulic turbine and a hydraulic pump. So the basic difference between these two is they will work in opposite. Now let us try to understand some definitions that are related to boilers. Okay, so let us see what is the basic definition of a boiler. A boiler is a closed vessel in which the water under pressure is transferred into steam. So the boiler is a closed vessel, we know that. So in this closed vessel, we will take some water, we will boil it, which will be converted into steam. This device is called boiler. The function of a boiler is to transfer heat to the water in most efficient manner. So the function of the boiler is not only to heat water, it should also take whatever the heat that is given to the boiler, this entire heat should be supplied to the water in a most efficient manner. Otherwise, there is no use of using the boiler. We can do this by simply putting a jar of water on a stove. We can do this. But if we want to heat the water in more efficient manner, we have to use boiler. The boiler should be designed in such a way that it will take the entire amount of heat to be supplied to the water for boiling. And then the boiler must be designed in this manner to absorb maximum amount of heat released in the process of combustion. So we take coal or some fuels like petrol, etc. for boiling of water, or we will use LPG gas. So when we burn these fuels, we have to use some device like boiler, which will convert this heat, which will supply this heat in a most efficient manner. So this is one definition, that is the basic definition of any boiler. So there are different types of boilers in the industry and market, which are being used for the production of steam. They are like fire tube boilers, water tube boilers. There are some named boiler types are there, like Lancashire boiler, Babcock and Wilcox boiler, Cochrane boiler, etc. So all these boilers will do one similar thing, that is, they will produce steam by boiling water. So they will follow different types of techniques in order to do this, even though they all have the same purpose, that is production of steam in a most efficient manner. Now let us try to see different types of boilers like fire tube boilers. So what is a fire tube boiler? Fire tube boiler is a boiler in which the hot flue gases that are emitted from the combustion of the fuel, okay, whatever the hot gases they are coming while the combustion of the fuel is happening. So these hot gases will be sent into pipes. So these pipes are surrounded with water. These pipes are completely surrounded with water. So whenever the hot gases are flowing through the pipes, so generally these pipes are made up of metal, mostly iron or steel. So they can conduct heat from the hot gases flowing through the pipe, and this heat will be supplied to the water surrounding the pipes. Okay, so hot gases, when they are flowing through the pipes, the heat will be supplied to the water which are surrounded by the pipes. Okay, now this is how the heat is supplied to the water, and the water will boils. Whenever the boiling of water takes place, the boiler will produce some amount of steam. Now this is called fire tube boiler. And then we have another type of boiler, that is water tube boiler. So in water tube boiler, what happens is the water will be flowing through the pipes. So we have a boiler is there. Inside this, we will keep some pipes. Inside the pipe, we will make the water to flow, water inlet and water outlet. So what happens when the water that enters at this point at the inlet, while it is moving through the pipe from leftmost point to the rightmost point, the water will be heated and steam is generated. Okay, we not only make the water move from one place to another place, while moving from the end points, the water will be boiled by supplying heat. We will take some fuel here like coal. The coal will be combusted. The heat from the coal will be supplied to this pipe. Now this is very simple working, like in a simple vertical boiler will works in this manner, where we will keep this pipe in an inclined position so that the water will easily flow through the pipe without any pump. Due to gravity, the water will easily flow. So this is a water tube boiler. That means water is present inside the tube and heat is supplied from the outside. Whereas in fire tube boiler, hot gases will be flowing through the tubes and water will be surrounded these tubes so that the heat exchange will be done. Okay, so these are boilers. There are two types of boilers are there, fire tube boiler and water tube boilers. And then we have different mountings that are attached to the boiler for the perfect working. Now we will try to see what are the definitions that are related to these different types of mountings that are connected to a boiler. So the first one is water level indicator. So generally any boiler will have a area where water is taken, because ultimately we have to produce steam for which the raw product is water. So in order to produce steam, we have to use water. This water has to be taken into a tank which is closed, obviously, because we have to close the tank in order to supply heat. Otherwise the steam will be escaping into the atmosphere. There is no use of heating the water. So whenever we take water and heat it, it will be heated and the formation of steam will be seen. So we have to take this water in a closed container or a tank. Because it is closed, we cannot see manually what is the level of water present inside the tank. So we have to use a separate device called water level indicator. The function of this water level indicator is to show up to which level the water is present inside the boiler tank. Okay, so water level indicator is a very simple device. If this is the water tank and in this water has been there up to this level, we will connect a device by using 2 or 3 pipes. There will be connection. 2 pipes will be connected like this and 1 vertical pipe will be connected to these 2, where we can see the level of water. So whenever a valve is opened here and here, so these 2 are valves. So when the valves are opened, the water will flow into these 2 pipes. Okay, depending on the level of the water inside the boiler tank, the same level will be shown here. So this is level of water. So water flows into this tube. It is a glass tube, so that we can clearly see how much level of water is present in this tube. Okay, so this is the function of water level indicator. And then we have a second device, that is pressure gauge. So the function of a pressure gauge is that it will show or indicate the pressure of the steam that is generated inside the boiler. So if this is boiler, we have water. When we boil this water, we can see the formation of steam here. This is all steam which is in the gaseous form. So here we will connect a small device called a pressure gauge, which will indicate the pressure of this steam. Okay, we have already seen the working of this pressure gauge in the previous lectures. We can refer them. And then third device is safety valve. So the function of a safety valve is very similar to that of a device that is connected to the household pressure cookers, which we use in our homes to cook food. So in this, we have a safety valve, that means the whistle which will blow when the pressure is high enough so that it will remove some amount of steam from the pressure cooker. Similarly, the same thing is applied in case of boilers. We have a pressure valve or a safety valve which will open and makes the steam escape whenever the steam levels are very high. Okay, so we are continuously producing steam while boiling the water. The steam, when it is not utilized at some point, okay, because we have to use the steam which is produced. So if we don't use the steam will get accumulated inside the boiler tank. Now, what happens if the pressure of the steam is increased very much? Like if the pressure is very high, the boiler tank may explode due to the excess pressure that is created inside the tank. So we have to have a safety measure in order to control the explosion. So for this, we will keep a safety valve. The function of this safety valve is to, so safety valve generally have a dead weight which is kept on its opening. So whenever the pressure is more than the weight of the dead weight, so the dead weight will be lifted. The same principle what we see in domestic pressure cooker. So whenever the pressure inside the pressure cooker is more than the weight that is kept on the safety valve, so the weight will be lifted up and the steam will be sent out. Okay, the steam will escape into the atmosphere. So the same principle is happening in the case of boiler tank. When the pressure is more, the dead weight will be lifted and the steam will escape into the atmosphere so that no explosion will take place for the safety of the boiler and also the persons who are working near the boiler. And then the fourth device is junction valve. So junction valve is a device or a valve which is used to control the flow of steam. Okay, we can control the flow of steam that is coming out of the boiler. So our goal is to produce steam, to use it somewhere. Like we can use this steam for the production of electricity when it is sent into a turbine, or we can use this for cooking food, etc. So we have to collect this steam. So we should have a valve that is connected to the boiler tank. So that valve is called junction valve. And then fifth device is feed check valve. So we have already said that into the boiler we have to take some water. So this water has to be sent into the boiler by using a valve and a pump mechanism. We need a pump here, and this pump will drive the water into the boiler tank. Now, in order to maintain the flow of the water into the boiler, we have to use this feed check valve, which will be operated in order to make the water flow into the tank, that is boiler tank. Okay, so this is simply a boiler valve which is opened to make the water flow into the boiler. And then blow off cork. So blow off cork is a device which is used to remove to drain the wastewater that is present inside the boiler. Okay, whenever there is a boiler is there, the boiler has to be cleaned. In order to clean the boiler, we should have some kind of opening, because the entire boiler is filled with water. We know the water will contain large amount of carbonates and bicarbonates. Due to heating, these salts will be deposited on the inner surface of the boiler tank. Now, we have to clean this somehow. After some working days, we have to clean the boiler inside so that we can use the boiler more effectively. Due to the formation of scaling, there are many disadvantages, like heating cannot be done properly, or the steam which is formed may not be collected easily because of the formation of this scaling. Okay, we know that scaling is a method where the salts that are present in the water will get deposited in the tank due to heating. Okay, now in order to clean the tank, we should have an opening at the bottom of the tank So that is called blow off cock. So this is a valve that is opened, and the wastewater will be collected through this blow off cock. And then seventh device is fusible plug. Now this fusible plug is a device which is added for the extra safety of the boiler tank. Now we have seen that the third device, safety valve. Safety valve is a device which is used to remove the excess steam when the steam pressure is very high. This is very similar to pressure cooker again. Now, if you carefully observe, the domestic pressure cookers will have a separate fusible plug, a separate opening on the surface of the cap, okay, for the pressure cooker. So, what is the function of this fusible plug? Suppose we know that the safety valve is an opening which through which steam can flow. Suppose if this safety valve is blocked by some kind of scaling or any kind of dust particles, what happens? The steam cannot escape through this safety valve. Then what happens? Again, there is a risk of the increase in the pressure of the boiler tank. Then we should come up with a separate mechanism or a extra additional safety measure in order to protect the boiler tank from an explosion. So that is fusible plug. So fusible plug is a device which is made up of, it is also connected on the surface of the boiler, just like a pressure cooker. So this is made up of metal but a very thin size. Whenever the pressure is more than the rated pressure of the safety valve, it will simply blow off. That means it will be exploded. The small fusible plug will be burnt out so that the steam will escape into the atmosphere. So the fusible plug will be kept in order to give additional safety for the pressure cooker as well as the boiler. Both works as a similar manner. Okay. So fusible plug, it is used for it is used in cases where the safety valve may not work. And then eighth device is manhole. We know the boilers are very large sized devices. They are of 100 to 200 meters high, and they should have a diameter of around 5 meters to 10 meters. So boilers are very huge. So they need cleaning. So in order to access, if a person has to access inside the boiler, we should have some manholes, so that the manholes are covered with doors. They can be opened, and human beings or operators can go inside and clean or do some maintenance work related to the boilers. So this is manhole, which is used for cleaning and maintenance. And then anti-priming pipe. So anti-priming pipe is a device. It prevents the flow of water particles that are contained in the steam. So what is anti-priming pipe? It is a pipe which is connected at the junction valve where we will collect the steam. So junction valve is the place where we will collect the steam. At this point, we are going to connect a anti-priming pipe. The function of this pipe is to stop the moisture at this point before sending the steam into required place, because the freshly made steam will have some level of moisture present in it. So we have to remove this moisture in order to protect whatever the machines that are being made up of metal. Because of the moisture, the metals, the machines may get corroded. Okay, so we have to remove this moisture present in the water. So in order to do this, moisture present in the steam. So in order to do this, we arrange this device called anti-priming pipe. Now these are all 9 types of boiler mountings. Apart from these, we have some other devices. They are called boiler accessories. So boiler accessories and boiler mountings. Now let us try to understand the difference between boiler accessories and boiler mountings. Okay, boiler mountings. So boiler mountings, what is the function of this boiler mountings? So without boiler mountings, the boiler cannot work. Okay, so mountings are mandatory. They has to be fitted to the boiler in order to make the boiler work. But whereas accessories are the devices that are added to improve the efficiency or working of the boiler. Okay, These are additional features that are added in order to improve the quality of the steam or to improve the efficiency of the boiler. Okay, these are not mandatory devices. Okay, mountings are only mandatory devices, but accessories are additional features. So they can be added or not, even though the boiler can work. Okay, now let us see the definitions of these boiler accessories. The first one is air preheater, where air will be preheated, okay, before sending it to the furnace. Now, let us try to understand the whole procedure. We have seen this already. So, there is a furnace, there is a boiler tank, and inside this boiler tank, we will collect the steam. Okay, this furnace is generally placed inside the boiler. Suppose if I take a simple vertical boiler, here I have a furnace, this is furnace, and this is all boiler inside which we have water. Now in furnace, when I supply some heat by combusting coal, so I need some air. Every time I need fresh air in order to burn the coal. Why do we need air? Because we need oxygen for the combustion. Okay. Now what happens is, I will take a pipe to which I will collect a air filter. From this air filter I can collect atmospheric air. Okay, this is all general. But what happens is, the function of air preheater is to heat the air before it is being sent to the furnace. Now this air is heated by using the heat that is coming out of the same furnace. Okay, we know when we combustion takes place, very large amount of heat will be developed. This heat is used to boil the water. After that, these gases are let into the chimney. Okay, these gases are let into the chimney where they are escaped into the atmosphere. Now what happens is, I will take a pipe and I will connect this flue gases, hot flue gases will be connected to the fresh air coming. Okay, I am not going to mix the fresh air with the dirt smoke. I am going to heat the fresh air with the help of hot flue gases. So the hot flue gases which are going to be left into the atmosphere, they are reused for preheating the air before the air is sent into the furnace. So what happens when the air is preheated? That means the air will generally have some normal room temperature will be there. But whenever I preheat this air, the air will attain some temperature where the combustion of the coal will take place more efficiently and more rapidly. I am repeating this. The preheated air is used in the combustion of the coal to improve the efficiency and also the quality of the combustion. Okay, so that is why preheater is used. So air preheater is an addition. It is not a mandatory device to be used, though it can improve the efficiency of the combustion. So more amount of coal will be combusted effectively. Second device is economizer. So economizer is a device which uses the heat from the hot flue gases and it will heat the feed water. Now here we will see what are the hot flue gases that are being let into the atmosphere. They are being used for heating the air. Just now we have used the flue gases for preheating the air. Now the same hot gases can also be used to preheat the water. Why do we need to preheat the water? Because in boiler, we have water that is at room temperature. So this is all water. This water is present at room temperature. Now what happens is, when this water has to be lifted from room temperature to boiling point, that is 100 degrees centigrade, where it can generate steam, I have to do extra work, like I have to do some X work. Okay, so this is the work I should done in order to increase the temperature of water from room temperature to boiling point. Now what happens is, I will use the hot flue gases. Hot flue gases are the gases that are emitted from the furnace. These are first supplied to the water. After boiling of the water, these gases are waste. They are ultimately sent into the atmosphere. Now I am reusing these hot gases by a device called economizer. This economizer will supply the heat of these hot flue gases to the water. So what happens? The water also will be preheated before it enter into the boiler tank. Now what happens is, I will heat them a small amount of dx. That means a small amount of work has already been done by the hot flue gases for increasing the temperature of the water which is being sent into the boiler tank. Now, ultimately, what is the amount of work I has to do in order to heat the water? So, as the temperature of the boiling water has already been increased from the room temperature because I have preheated the water with hot flue gases. Now, x minus dx will be the final amount of work should be supplied to the boiler from the furnace. Okay, so this delta x or dx is the amount of heat that is supplied from the hot flue gases, so that I can remove this work or I can save this work for next set of operations. Okay, that means I can save some fuel for the coming next cycles. Okay, so economizer is a device which will preheat the water. Air preheater will preheat the air. Now, third device, injector. The function of an injector is to inject water into the boiler. So it is just a pump which will drive the water into the tank. Simple. There are different types of pumps are there. Mostly centrifugal pumps are used for driving water into the boiler tank. And then fourth device, feed pump. So the feed pump is a device which is used to deliver feed water into the boiler. So this is also very similar. Okay, we will use some kind of pump for sending water. And this one, superheater. Now observe carefully, superheater is a device which uses the heat from hot flue gases or furnace, and it uses this heat to reheat the steam. What is reheating? We know what is preheating. Preheating is the process where we will heat the water or air before they are sent into the boiler or furnace respectively. And we have another technique called reheating. So the technique reheating is nothing but, we know a freshly made steam contains small amount of moisture and water droplets. Now this moisture that is present in the steam is not suitable for the working of many turbines, and it is not required where the applications are. So I have to remove this moisture from the freshly made steam. So in order to do that, I will reheat the steam. So by using a device called superheater. Why it got this name is, the steam which is reheated will attain a temperature called superheated temperature, and the steam is also called as superheated steam. Now the meaning of superheating is reheating the steam so that the moisture present in the steam will be completely eliminated. So it is completely converted into gaseous state. There is no moisture present in the steam. So this steam is very suitable for the working of turbines, where the turbine will rotate with the help of this steam and it will produce electricity. So these are the 5 different types of devices or accessories which are used in boilers, where using these type of accessories will increase the efficiency of the boiler. Now let us try to see some basic definitions of any hydraulic turbines. So first one is gross head. Gross head is nothing but it is the head. It is the height of water that is present inside the reservoir. So if this is reservoir, we have some level of water. So this is called Hg. It is represented with Hg. It is written here. So this is the height of water from the tail race. Here this is tail race. Tail race is nothing but it is the level of water in the tank which is placed below the turbine. Okay. Now the difference of this height from the tail race to the head race, that means level of water in the reservoir to the level of water in the tail race. This difference is called Hg, that is gross head. And also we have other definitions like net effective head. So net effective head is nothing but it is the head available at the inlet of the turbine. Simple. It is the head available at the inlet of the turbine. Why it is different from gross head? Because whenever the water is made to flow through a pipe, this pipe is called penstock. So whenever the water is flowing through this penstock, it is very long pipe. Okay. So whenever the water is flowing, due to friction between the inner surface of the pipe and the water, the head will be lost. Some amount of head will be lost. So we have to subtract this loss in the head from the gross head, so that we will get, this is gross head and these two are the differences that are being subtracted from the gross head in order to get effective head. Okay. So H is the net effective head, which is calculated. So it is the head available at the inlet of the turbine. Okay. Now another formula is HF. So HF is nothing but, so this is what we have subtracted here. So see here, this is HF. HF is the head of the water lost due to friction. So HF is head loss due to friction. So the formula for head loss due to friction is 4FLV square divided by diameter into 2 times the gravity. So F is the friction coefficient, L stands for length of the pipe, V stands for velocity of the water flowing through the pipe, and D stands for diameter of the turbine wheel, and G stands for gravity. So using this formula, we can actually calculate the head loss due to friction. So when the water is flowing through the penstock, because of its huge length, some amount of head is lost during the flow. So that is calculated as HF. And we have some other formulas like hydraulic efficiency. So if we see the definition of hydraulic efficiency, it is the ratio of power developed by the runner to the power supplied at the inlet of the turbine. Okay. So power developed by the runner to the power supplied at the inlet of the turbine. So this ratio is called the hydraulic efficiency. So what kind of powers we are considering here? There are two powers, that is power developed by the runner. That means runner power divided by power supplied at the inlet of the turbine. So this is water power. So whatever power that is given by the water, so that is taken in the denominator, which is headed over with runner power. Okay. So this ratio is always called as hydraulic efficiency. And then we have another efficiency, that is mechanical efficiency. Mechanical efficiency is the ratio of shaft power. So power available at the turbine shaft and the power developed by the runner. So this can be written as shaft power and runner power. Shaft power to the runner power. So previously what we have written in the previous efficiency. So this is runner power to the water power. It is the ratio of runner power to water power. Remember this. Here mechanical efficiency is nothing but shaft power to runner power. And then we have another efficiency, that is volumetric efficiency. Volumetric efficiency is nothing but it is the volume of water actually striking the runner to the total water supplied by the jet of turbine. So as we know, when there is a moving turbine, it will be supported with the help of jets. We have different jets placed at different locations. Not only single jet is placed, we have more than one jet for the flow of water which is coming through the penstock. Okay, this water can be utilized in such a manner to increase the efficiency of the turbine. Okay, we can place more than one nozzle. So volumetric efficiency is the ratio of water actually striking the runner, discharge actual, divided by discharge that is given by the nozzle. Okay, so this is volumetric efficiency. So far we have seen three efficiencies: mechanical, hydraulic and volumetric efficiencies. And last efficiency is overall efficiency. So what is overall efficiency? So this overall efficiency will compare the initial and final stages of powers developed. So power available at the turbine shaft is taken in the numerator and the power available at the water jet is taken in the denominator. So this ratio is nothing but shaft power over water power. So we have seen in the previous slides. Now let us go back. So this is hydraulic efficiency. Hydraulic efficiency is nothing but Rp by Wp. Okay, that is what written here. Rp by Wp. So this is hydraulic efficiency multiplied by this mechanical efficiency. Shaft power by runner power. Mechanical efficiency, shaft power by runner power. Now what happens if I multiply these two things? I will get a new value, that is, these two things are gets cancelled and I will have shaft power by water power, which is the overall efficiency. So this is the shaft power by water power. This is overall efficiency. So there is a relation between these three efficiencies, which is given as overall efficiency is equal to hydraulic efficiency multiplied by mechanical efficiency. So using this formula, we can solve some type of numericals, and also these are used for the design of a hydraulic turbine, where they can be effectively designed by using the different values of efficiencies. Now, let us see what is cavitation. So cavitation is nothing but formation of bubbles inside a turbine when it is working. These bubbles are rapidly formed and they will rapidly collapse, forming a jet. So here we can see microjet formation is there. So this microjet is the reason for the cavitation. Cavitation is nothing but forming a very small shaped, very small sized cracks on the surface of the turbine blade. So these cracks are very dangerous because they may cause catastrophic failure, like they will break the turbine into two parts when they are not observed carefully. So the cavitation is the phenomenon where bubbles are rapidly formed and collapsed, and they will severely damage the surface of the turbine parts. So this phenomenon is called cavitation. So, and then what is called a concept called priming is there. So in centrifugal pumps, we have a thing called priming, where we have to fill the casing with water in order to create a forced vortex inside the water, so that this phenomena will create a suction at the center of the casing. So this suction can be used to suck the water from the sump and the water can be lifted up. Okay. So cavitation is the phenomena of filling the casing and impeller with water, and sometimes the suction pipe is also filled with water in order to create a suction inside the centrifugal pump. So priming is only seen in centrifugal pump. It is not related to reciprocating pump. Okay. Now, so far we have seen different terminology that are related to boilers and turbines, and we'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.